Alright guys, let's get your homers out. Let's do this. The first question is a light bulb one, so I'm going to look and see how things work. I know that when A is removed, B, C, and D are on. So they're probably in series with each other when A is off. But it can't be that easy. Looking at B, if B dies, A and C are on. So that means B and D have to be in a line, but A and C necessarily not. So looking at that, with C, if C is removed, they all die. So C's got to be itself, and then B and D in a line, and then A's by itself. So that's going to be the answer. Let's make sure. If D dies, the B's got to die, which is true, then C and A are on, which is true. So there we are. Next up, looking at this, series circuit. Okay. I'm going to start by putting my voltages in and drawing them in. 6, 7, 11. 11's kind of small there, my bad. This means I'm going to make a table. VIR. I'm going to put my 6, 7, 11 in. If I can actually see this. And I'm going to end up getting 24 ohms for the resistance. And then when I do V equals IR, I'm going to get 0.0625 amps for the current. So if there's 5 coulombs of charge, how long would it last with that current? Okay, coulombs of charge is Q. I know I equals Q over T. And I'm going to solve for T. I'm going to get 80 seconds. Don't worry, I actually pan down in a second. So there we are. I know they all have the same current because they're in series, so they all have 0.0625. And I got to find the voltage of the 6 ohm. So I'm going to do V equals IR. I know the I for all of them. I get 0.375. That's my voltage for the 6. That's how much it dropped by. Now, if I switch the 6 to a 5, what's going to happen? Well, the resistance will go from 24 to 23, so the current's going to go up. So they all get larger currents. The current goes up. Now, which one gets the most powerful? Twinkle, twinkle, little star, power equals I squared R. And they all have the same I's, so all that matters is R. So the most R's would have the most power in this case. Looking at the second situation, though, it's going to be a little bit different. So here we have a parallel one. Let's get it out. 6, 7, 11 now in parallel. Okay, parallel probably means they're going to have less resistance overall than before. There I am. I'm making a chart, 6, 7, 11. I know that they have the same voltage, but not the same current. So they all have 1.5 volts. I'm going to use my equation for 1 over 7 plus 1 over 11 plus 1 over 6, and then 1 over that. And I get 2.5 around. Do V equals IR, and I get 0.6 amps. So that's the total current. So in parallel, there's higher current. Why? Because they have separate paths. Doing Q over T equals I. I'm going to solve again for the time, but I get 8.3 seconds instead of 80. So the series lasts longer because there's less flow. I'm going to find the current through the 6 ohm. They all have 1.5. I'm going to do V equals IR for that one. And I'm going to get 0.25. So there's 0.25 amps through it. And now I'm going to do P equals V times I. Since they all have the same V, more I equals more power. Or I can do V squared over R, where since if you have more R, power goes down. Just to find the currents, there you go. You know the least resistance has the most flow. The 6 would have the most power. So in series, most resistance, most power because of they have the same flow. In current, most resistance is the least power because the flow can actually split. So finally, let's look at this cute little thing. Which resistor will have the most current? It's got to be R1 because it has all the flow before it splits. Which resistor will the ammeter read the current? It's got to be just R2 because that's the only things that are in its path. In other words, the ammeters only measure the flow of things they're in series with. Which one will the voltmeter read? Well, if I draw this cute little picture here, goes to R1, R2, and R3 have the same resistance, and the voltage thing you see there is branching those 2 points, which means it's going to show the same voltage as R2 and R3. So it only measures the voltage of things it's in parallel with. And that, my friends, is a solution and a half. Thanks and have a good day.